So welcome everybody to this latest video 162 Maths, and in this video we're going over the AS Maths Mechanics topic of Objects in Contact Part 3 with a focus on pulley systems. Now before we get started working through some problems relating to pulleys and objects in contact, let's just have a look at some key terminology. Now a fixed smooth pulley is a fixed wheel over which a string is passed. Now there is no friction between the string and a pulley. Now with this, friction is a thing that is covered in year 13 or A2 maths, so if you are working at a S maths, then yes, you need to be aware of friction, but no, you don't need to take it on board. Now another thing that we need to think about when we're looking at pulleys is that the tension in a light inextensible string which passes over a smooth fixed pulley is constant. Now basically what this relates to is if we had a piece of string just simply being dangled here, and let's say we had some form of mass on there. Now if I was pulling at the string at the top, then what I would find is that there's going to be a lot of tension at the point in which I've got the force pulling that piece of string, and I'd have less tension here. Now what this constant tension is telling us is that the tension in this whole entire string is going to be the same. It's a bit like if you have your hand pointing in a vertical motion towards the ceiling, and let's say you're wearing a long sleeve top. If you were pulling your top, you'd feel your material, your sleeve would feel more of the tension where your hand is pulling rather than at the point that is furthest away. Now what this is talking about when you're talking about tension in a pulley or even a tow bar like we covered in the previous video when we looked at cars and trailers, is that the tension in the toe, and in this particular point the tension in the string, is going to be constant. So how you want to see this pulley is that when we had a tow bar we had tension going in both directions. Well, here in the pulley, again remember tension is a pulling force, so therefore on both sides of that pulley that we've got tension going in the upwards direction, in other words towards the pulley from the actual particle. Now what that also means is that the tension on one side is going to be equal to the tension on the other. So if I call this T1 and T2, then what I know is that T1 is going to equal T2. Now in an exam or in a particular problem, as we go through some examples, we want to try and shy away from using T1 and T2 because that kind of gives the impression that they are both different values. So what you want to do is just call it T and you'll be absolutely fine. So let's start just by getting rid of those numbers and again just calling it T. Now just like we talked about in the previous video, it is important that you write down units, particularly when you're talking about mass, because mass needs to be written in kilograms and forces are looking at newtons, and you want to make sure that those units are fixed. That try and stay away from actually writing the units. So always check before you start a question to make sure the units are consistent and in the right unit. But in terms of actually noting it, unless it's your final answer, I would leave it alone, simply because what you don't want to do is be overloaded with different variables. Now when you're working with pulleys, there are a few assumptions that either need to be made or that will be stated in the question. Now the common assumptions are that a smooth pulley is used, and with a smooth pulley being used, in that the magnitude of the tension is the same on both sides. So again, as we mentioned on that previous slide. Another assumption is that we have an inextensible string and that the magnitude of the acceleration is the same for both particles. So here we're talking about the stretch in the string or the cable that there is. Once one goes up, there's no additional length that we're talking about. We also need to take on board another assumption that the string or the cable that we have is light. So in other words, if we know it's light, then we can ignore the weight of the string in any of the calculations that we do. So now let's have a look at the most common notation related to pulley questions. Now with regards to a pulley question, generally speaking, more often than not, you're going to have different mass loads, because if you had the same mass load on each of those two particles, then what you'll have is that the pulley will just balance the two sort of particles. But usually what you're looking for is that the pulley will be going down on the particle that's got the greater mass. So the pulley will go down at the heavier weight. So for example, if A was, so if the weight of A is greater than the weight of B, then it's going to be going down and that side is going to be going up if we call this B. Now if the weight of A is smaller than the weight of B, then what we'll have is we'll have the weight, the pulley going up and also going down at this particular stage. Now, why is this important? Well, it's going to be important in the structure of how we sort of arrange our resultant force in relation to F equals ma. Now, when we're looking at this, we always have our tension going in the opposing direction of the actual force, because remember, tension is a pulling force, so we're going to be pulling and keeping those particles supported by the pulley. So if that's going to be T, then this is also going to be T as well, and that's to be going in a upward direction. Now also with this, we are going to have mg going down, and as we mentioned, that if I just label these particles A and B, and in which if A, or the weight of A I should say, so if the weight of A is greater than the weight of B, then what we're going to have is the acceleration going down and this acceleration going up. Now if I just change color, so if the weight of B is greater than the weight of A, then what you'll find is that the acceleration then is going down on B and is going to be going up on A. So it does switch between the two. So it's not always the left hand side that's going up or the right hand side that's always going down. It could be vice versa, in which what you'll need to do is read the question carefully. Now once you've established, now just for the sake of this, let's just pick one of the weights that's greater. So let's say, for argument's sake, that A weighs more than B. So let's say A weighs, let's say 6 kilograms and B weighs 4 kilograms. Then what we will have is, and let's just label this, so we've got 6 kilograms and 4 kilograms. Then what we'll have is we'll have the pulley going in a downward direction on the left hand side, and that string B is going to be going up, and so both of those are going to be at A. So then working with the force of A, so if I just label this as side 1 and this is side 2, then looking at side 1, what I'm going to have is that I've got mg going in the same direction as A, so using F equals ma, so F is going in, mg is going in the same direction as A, so that's going to be mg minus T equals ma. And if I look at side B, that's where T is going in the same direction as A, so that's going to be T minus mg equals ma. And the key thing to remember is which force goes first. It's the force that's going in the same direction as A. Then once we've got that, now again, if I had it in the other direction, so let's just get rid of all of this, and again let's switch these two things around. So let's say B weighs more than A, then what we'll find is that now the pulley is going to be going down at our heavier weight, which is at 8. So again, let me just get rid of all of the labeling so we're not getting confused. So here we've got 8 kilograms on B and 2 kilograms on A. So that means our pulley is going to be going down on B and it's going to be going up on side 1. So now side 1 is going to be T minus mg equals ma, and side B is going to be going where it's going to be mg minus T equals ma. And again, it's just a case of deciding from the basis of the question and the information that's given as to which order we write our F equals ma. So now let's have a look at an example question. So in this example question, it says that particles A and B of masses of 5 kilograms and 8 kilograms respectively are attached to a light inextensible string. The string passes over a smooth fixed pulley and the particles start at the same length and are released from rest. Find the acceleration of the particle and the tension in the string. So let's have a look at some key wording with this. So one thing that you should be able to spot is the fact that we've got our assumptions. So we know that the string is both smooth, fixed against that pulley. And we also know that they're at the same length and they're released from rest. We also know that the masses of A is 5 kilograms and the mass of B is 8 kilograms as labelled in the diagram. And the question is asking us to find the acceleration and the tension in the string. So they're the two things that we then need to find. So I always encourage students to always start by labelling the tension first. So let's put that on the string. So we've got T going upwards, and going down we have mg. Now, looking at the weights of the two particles, that B is heavier than A, so that means that the pulley is going to be going down on the right hand side and is going to be going up. That string is going to be going up on the left hand side. So if I then label each of these, so I'm just going to call this A and B. So if I look at side A, then using F equals ma, remember F is the resultant force, that we have T going in the same direction as A, so it's going to be T minus mg equals ma. And then if I substitute the numbers in, so I know that the mass is 5 kilograms, and I also don't know what g is, so I'm going to assume that g is 9.8 meters per second squared. So here what I can then do is substitute that in, so I've got T minus, and it's going to be 5 multiplied by 9.8 equals 5 times A. Now I can neaten some of that up, in which I get 5 minus, and it's going to be 5 times G, which if I type in my calculator, I get an answer of 49 equals 5A. Now there's not much I can do with that, so I'm just going to put a little box around that. Then if I do the same for B, so looking at B, I've got the force that's acting in the same direction as A, which is mg, minus the opposing force, which is the tension in the string, equals ma. Now again, substituting the numbers in, I've got 8 times 9.8 minus T equals 8A. And again, neatening this up, I get 8 times 9.8, which is 78.4 minus T equals 8A. Now, apart from that, because I don't know what T or A is in this particular question, that's pretty much all I can do with that equation. Now, what do I notice about these two sort of equations I've put in boxes is the fact that I've got two unknowns and I've got two equations. So when I think of two unknowns and two equations, what should come to mind? Simultaneous equations. So from this, what we then need to do is use simultaneous equations to find A and T. Now, before I use my calculator to do this, what I need to do is make sure that they're in the right format and the signs are correct before I start plugging this into my calculator. So if I look at this first one, what I'll do is put all the letters on one side and numbers on the other. So I've got t minus 5a equals 49, and that's just from this one here. Then for the second equation, I'm going to write minus t minus 8a equals negative 78.4. So then entering this on my calculator, I get a t value of 60.3 newtons, which rounded gives me a t value of 60 newtons, and that's to one significant figure. And I get an a value of 2.26, which rounded gives me 2.3 meters per second, and that's to two significant figures. Now again, be careful with your rounding. If it doesn't mention anything in the question, always write down an accurate answer and then round, and make sure you state what you've rounded your answer to. So now let's have a look at another example that's very similar. And again, if you're wanting to have a go at this question, just pause the video at any point, have a go at the question, unpause, and then we go through the answer. So in this question, it says two particles A and B of masses of 2 kilograms and 12 kilograms respectively are connected by a light inextensible string which passes over a light smooth pulley. Find the acceleration of the system and the tension in the string. So again, what we want to recognize is that we've got tension going upwards, and going down we've got mg. Now this is basically our mg, which is written as 2g in this case. So you do not want to get confused of thinking that is 2 grams and 12 grams. It's basically the mass times gravity. Now in this, we're going to take gravity as being 9.8 meters per second again, and what we notice is, let's just label the sides. So because there's more weight on B, that means that it's going to be going down on B and going up on A. So looking at side A, what we have is we're going to have T minus mg equals ma, and on B I'm going to have 12g, well let's say I'm going to have mg minus t equals ma. Then from this, what I then need to do is substitute the numbers in. So I've got t minus, and it's going to be 2g equals 2a. And what I've then got on the b side is I'm going to have 12g minus t equals 12a. And again, what we then need to do is rearrange these formulas. So we have letters and unknowns on the one side and letters on the numbers on the other. So here I'm going to have 2 times 9.8, so that's going to be t minus 2a equals, and that's going to be 19.6. And on this side I'm going to end up with minus t minus 12a equals 12 times 9.8, so I'm going to have minus t minus 12a equals, and that's going to give me minus 117.6. Then using these two equations and simultaneous equations, so solve via simultaneous equations. And again, if you've got a calculator that does simultaneous equations, don't be a hero and try and solve it algebraically. Just plug it in the calculator, check it's correct, make sure the signs of each u variables are correct, and then just hope that it gives you the right answers, in which if I type this in my calculator, I should have an answer of 7 meters per second for acceleration, and the tension should be 33.6 newtons, or 34 newtons to 1 SF, and that's to one significant figure in both of those two answers. And there we go. So again, now looking at our third example. So this question again, very similar, of a similar context. It says two particles A and B of masses 11 kilograms and 16 kilograms respectively are connected by a light inextensible string which passes over a light smooth pulley. Find the acceleration of the system and the tension in the string. So again, exactly the same question, just using different numbers. So again, my tension is going up. A weighs less than B, so B is the one that's going to be going down and A is the one that is going up. And again, in the question, this is my mass, so all of this represents mg. So looking at side A, what I have is I'm going to have T minus mg equals ma, and on B I'm going to have mg minus T equals ma. Substituting numbers in, we get T minus 11g equals 11a, and on this side I'm going to end up with 16g minus T equals 16a. Rearranging again, we get T minus 11a equals 11 times 9.8, and again we'll make sure that g is equal to 9.8 meters per second squared, and from this I get T minus 11a equals, and let's just work out what that is, and we get an answer of 107.8, and then for this one we get minus T minus 16a equals 16 times 9.8. 16 times 9.8 gives me an answer of 156.8, and that's going to be a negative, so it's minus T minus 16a, and these are my two equations which I solve simultaneously, and what I should end up with is a T value of 130 newtons and an A value of 1.8 meters per second square. So now let's have a look at an example which is similar to the pulley system, but this time we've got a pulley over a right angle. Now the context of this question, it says, on an adventure holiday, Dave falls over the edge of a cliff. Luckily, Dave is connected to Andy by a light inextensible string that gets wrapped around a smooth fixed boulder. After a short panic, Andy and Dave both begin to deaccelerate at the same rate. There is a resistive force of 940 newtons acting on Andy. Given that both Andy and Dave have a mass of 80 kilograms, calculate the tension in the rope and the deacceleration of Andy and Dave. So here we've got our pulley, we've got our assumptions in the fact that we've got a light inextensible string and that our pulley is smooth and fixed, so we don't need to worry about any particular movement in there. So the next thing that's left for us to do is then start labeling our diagram. So in this particular diagram, I've got tension, which is pulling away from Andy, which is T, and I've also got tension that is pulling against in the opposite direction to where Dave is kind of falling. So we've got T there. Now in terms of our acceleration, then what we have is we have our pulley going upwards in this direction, so going towards the right. And for Dave, we've got our acceleration, which is going in a downward trend. Now in the question, it also tells us that there is a 940 force acting on Andy. So that means that we've got a force of 940 newtons. And we also have a force acting down on Andy that keeps him grounded. We have our resistant reaction force, which is R, which is mg. And we've got our weight going down on Dave, which is also our mg. Now in this particular case, again, we're going to assume that g is 9.8 meters per second square. And again, if it's not mentioned in the question, in an exam, always check the front cover. They will always say you can assume gravity to be 9.8 unless told otherwise. Sometimes gravity we can written as 10, sometimes it can be written as 9.81, and again, if you've got free choice, just make sure you state whatever value of gravity you are using. Then in terms of substituting those numbers in, what we then know is that this is going to be 80g and Dave is also 80g. So that's what our mg values actually are. Now, in relation to Andy, the only reason why I need to know his weight is when we're looking at F equals ma, 80 is going to be my m value for Andy, and likewise with Dave as well. Now for Dave, we're looking at a vertical motion, so we're going to need to use mg when we're looking at the forces. So again, in looking at this question, if I split this part into two parts, so if I look at Andy to begin with, then what I've got in terms of his situation is I'm going to end up with T minus our resultant force, which is 940. So here I've got the force acting with, so this is again very similar to what we talked about with the car and the caravan, is for Andy, which is a horizontal force. And what I have is I have the force acting with acceleration minus the force or the opposing force equals ma, and that is my formation of F equals ma. So if I then substitute the numbers in, then I've got the force acting with acceleration, which is T, minus the opposing force, which is 940, equals 80 times A. Now again, there's not much I can do with that particular situation, so what I'm going to do is I'm just going to put a little box around that. Then if I look at Dave, now Dave has got a vertical force. So here I've got a vertical force. Now for Dave, it's the force acting with acceleration, which is my mg. So this is going to be mg minus T equals ma. And again, substituting numbers in, I'm going to end up with 80 times 9.8 minus T equals 80A. Now working out what 80 times 9.8 is, I get, and let's just quickly type that into my calculator, I get an answer of 784 minus T equals 80A. So just rearranging that, I get minus T minus 80A equals minus 784. Let's just put a little box around that. Now if I call this hashtag 1 and this hashtag 2, then using simultaneous equations, I get T minus 940 equals 80A. And let's just do a bit of rejigging on that one. So let's call that T minus 80A equals 940. And I've got minus T minus 80A equals minus 784. Then now I've got my two simultaneous equations. I can use my calculator to work out my T value, which in this case is 862 newtons, and my acceleration is going to be minus 0.975. Now the question did ask for the deceleration, so if acceleration equals minus 0.975 meters per second squared, then deceleration is going to equal 0.975 meters per second square. And so all that's left for me to then do is just highlight my two answers. So I've got the tension in the string, which is here, and my deceleration value, which is 0.975. So now let's have a look at another example similar to the previous one. It says two particles A and B of masses of 6 kilograms and 15 kilograms respectively are connected by a light inextensible string which passes over a light smooth pulley. Find the acceleration of the system and the tension in the string. So with regards to this, let me just write this a little bit clearer in the string. So Labeling this up, what we're going to do is we're going to first assume that gravity is 9.8 meters per second squared, and in this we've got our tension and we've got our tension here. Now because the weight is going to be going down at B, then that means that acceleration is going to be going downwards at B, which is going to then pull along A, so acceleration is going to be going in this direction here. Now looking at this again, we're starting with A. So looking at A, I've got, now it doesn't say anything about any resistant force on A, so I can just assume that that's 0. And the fact that A is not moving, all we know is that there's tension in that string that's moving in this direction with an acceleration of A, in which then what we've then got for A is going to be T minus 0 equals MA, which in this case is going to be 6 times A. So what I have is T equals 6A. Then for B, we've got our mg going down, and that's going with acceleration, so that's mg minus T, let's just label that T there, equals 15A. So I've got 15 times 9.8 minus T equals 15A. Then working that out, what I end up with is I'm going to end up with 147 minus T equals 15.A. Now what I then want to do is solve these simultaneously. So I've got T minus 6A equals 0, and I'm also going to have minus T minus 15A equals negative 147. Then solving this by adding, what I'm going to end up with is a T value of 42 newtons and an A value of 7 meters per second squared. So now let's have a look at our next example. It says the crate of mass 50 kilograms is attached to a light rope hanging over the edge of a wall and passing over a small pulley. A man pulls the other end of the rope, keeping it horizontal, and the crate is moving upwards with acceleration of 0.3 meters per second squared. Use G as 10 meters per second squared, giving your answer to an appropriate degree of accuracy. Find the tension in the rope. Now, as you can see in this particular question, we do not have a diagram, so let's first of all draw something that slowly kind of resembles this diagram here. So if I start by just drawing my wall, and again, just a little reminder, do not waste too much time on the diagram that you are doing. So here I've got my man and I've got my pulley, here is the string, and here is my crate. Now in terms of this, I know that the crate weighs 50 kilograms. I know that G is 10 meters per second square, and looking at this, I know that we've got tension, and tension is always going towards the rope, towards the pulley. Then along with this, what we know is we've got mg going downwards, and we've possibly got a force acting in this direction here. All we know is that the man might be moving, it might not, he might be stationary, he might just be pulling the rope, but all we know is that he's holding the rope and that the crate is going in an upwards direction. So we know that A is going in this direction, which means that the crate is going upwards, as it tells us that in the question. So in terms of my diagram and my labeling, that is what I've got. So let's have a look, and what the question is asking us to do is to find T. Is what I need to do. Now again, just very similar to regarding the car and the trailer, is that if we look at this as a whole situation, then I'm going to ignore T because the two T's are going to cancel each other out. So what I need to do is I need to look at this individually if I'm to find the value of T. So let's first of all have a look at the man. So looking at the man, I've got F potentially going in the same direction as A, minus the opposing force, which is T, and that's going to be equal to MA. Now in terms of looking at this, F we don't even know exists, so that's a big question mark. T is what we want. M is an unknown, and A, well, it does tell us what A is, and that's 0.3 meters per second squared, so that also is going to be 0.3 meters per second squared, because I'm going to assume that acceleration is constant throughout. So in terms of looking at the man, again, I can't really use that because there's too many unknowns in that particular situation. So now let's have a look at the crate. So looking at the crate, I've got T, which is going in the same direction as A, so it's going to be T minus mg equals ma. And then again, I know what mass is, which is 50, so that's going to be T minus 50 multiplied by g, which I know is 10, and that equals 50 multiplied by a, which I also know is 0.3. So taking and simplifying this, I get T minus 500 equals 15, and then taking the 500 over the other side, I get T equals 515 newtons. Now in the question it does say give your answer to an appropriate degree of accuracy. Now whenever it says an appropriate degree of accuracy, always look at the g value. So here I've got g as written as a number to one significant figure. So g is 10 meters per second, which is to 1 SF. So then what we then want to do is round our answer to 1 SF. So rounding 515 to one significant figure is going to be 500 newtons, and there is my final answer. So now let's have a look at a problem where it's really important that we set up our algebra properly. So in this question it says three particles A, B and C have masses of 11m, 14m and 13m. Particles A and B are connected by a light inextensible string that passes over a smooth light fixed pulley. Particle C is attached to particle B and the system is held at rest with the string taut and the hanging parts of the string vertical as shown. The system is released from rest. Find the tension in the string, and this question is asking us to give our answer in terms of m and g. So let's have a look at this particular problem. So first of all, let's start by labeling what we know. So we know that our tension is always heading towards the pulley, and that I've got mg going down on both ends. And what we know is that I've got more mass on the side of BC, so acceleration is going down on this end, which means that acceleration is going up on the side of A. So from this, now in terms of this particular question, we do not need to state a value of G as the question has insisted that the answer is given in terms of m and g. So here we're just going to call g, and again, another thing that's a little bit frustrating is that I've got masses in expressions of m. So again, m is in case of the mass of particle A, B and C is not the same, so it's 11m is m, and again you don't want to get to the point where you're cancelling the m's down. So I think this question is set up purposely to make sure that you're setting up the equation correctly. So if I call the side of A 1 and the side of BC side 2, let's have a look at side 1. Now side 1 we have T minus mg equals ma. Now in terms of this, what information do I know? Well, I know that m is 11m, so that's going to be T minus 11m g equals 11m a. Now again, if I neaten all of that up, then what I've got is T minus 11m g equals 11m a. I'll just put a little box around that to begin with. Then if I look at side 2, now mg is going in the same direction as A, so that's going to be mg minus T equals ma. Now m is going to be 27m g minus T equals 27 ma. And again, if I neaten all of that up, I get minus T minus plus 27 mg equals 11, or 27 I should say, ma. And let's put a little box around that. Now if I take both of those two equations and just write it up here, then what I end up is that t minus 11 mg equals 11 ma, and I've got minus t plus 27 mg equals 27 ma. Now the problem with this is the fact that yes, I've got two equations, but I've got three unknowns. I've got t, I've got m, which is not the mass, and I've got a, which is our acceleration. Now for this, because the question is asking me to find t, which is what I want, and I want it in terms of m and g, that does not involve a. So what I now need to do is to try and get rid of a. So try and get rid of a. Now one way of getting rid of a is to try and find if it cancels, but remember that these two expressions here are two separate equations, and so I can't just simply cancel a off, nor can I take them away, because if I do 11 ma take away 27 ma, I'm going to end up with minus 16 ma, which is not what I'm wanting. However, if I do take those two equations away, so let's add the two equations, then what I end up with is my t's disappear. I'm going to end up with 16 mg equals, and that's going to equal 38 ma. Now once I've got this, what I can then spot is that my m's, I can cancel an m from both sides, and from this what I can establish, I've got 16g equals 38a. So 16g minus 38 equals a. And if I put just a little bubble around that, now what I can then do is now substitute this into one of these two equations. So if I just call this hashtag 3 and this hashtag 4, so then using, let's go for hashtag 3 because that looks the easiest, in which I've got t minus 11 mg equals 11 ma. I know that a equals 16g over 38, and substituting this in, what I end up with is I'm going to end up with t minus 11 mg equals 11 m, and I've got 16g over 38. Now from this, what I can then do is, if I take the 11 mg over to the other side, I'm going to end up with t equals 11 m 16g over 38 minus or plus 11 mg. Now collectively that's going to give me t equals, and that's going to give me a total of 297 over 19 mg. And there is my answer of t in terms of m and g. And there is my answer. Now let's have a look at a trickier question. So here it says particles P and Q are connected by a light inextensible string passing over a smooth pulley. The mass of P is 2.3 kilograms and the mass of Q is 3.1 kilograms. Initially Q is held at rest at 0.8 meters above the floor and P is 0.9 meters below the pulley. Use G is equal to 9.8 meters per second squared, and giving your final answer to an appropriate degree of accuracy, the particles are released from rest and the system moves freely under gravity. Find A, the speed of Q when it reaches the ground. Now, like always, we're not given a diagram for this question, so let's start by drawing a diagram. So what we have is we've got our pulley, and what I've got is particle P, which is here, and I've got particle Q, which is here, and from there I can draw my tension on both of those. So here I've got T, here I've got T, and I've got my ground, which is here. I know that the pressing down on each of these is going to be mg. I know that the weight of Q is 3.1 kilograms, and I know that the weight of P is 2.3 kilograms, and so therefore acceleration is going to be going down at the Q side and going up on the P side. Now, along with that, I also know that the distance from Q to the floor is 0.8 meters, and I know that the distance from P to the pulley is 0.9 meters. And I'm also going to be using a G value of 9.8 meters per second squared. So in terms of my diagram, that is what I've got. Now in question A, it's asking me for the speed. Now in all our previous examples, we've been either working with tension or working with acceleration. This time we're working with speed. And whenever you think of speed, what should you be thinking about? You should be thinking about SUVAT. So with regards to question A, so to find the speed of Q, we need to use SUVAT. So in order to use SUVAT, what I need to do is, when starting these questions, is to start by writing down my variables. So I write SUVAT, and then it's just a case of filling in the information that I know. So in terms of S, the speed at which it reaches the ground, so it's going to be 0.8 meters. The U value is going to be, well, it's released from rest. So, and also it says that Q is initially held at rest. So U is going to be 0. And that's from initially at rest. V is what I'm wanting to work out. So this is what we want. And regards to the other two variables, I don't actually know what they are. Now, how do I then, in order to find V, I need to find either A or T. Now, in terms of based on what we know and what we've used in the previous examples, T is a no-go. I won't be able to find that out without working out any of the variables. However, A is a connecting variable that links forces to SUVAT. So in order to find V, so to find V, I need A or T. So to find A, we use F equals MA. So what I then need to do is use what I've done previously in the previous examples to work out what A is. So if I look at P and look at that in terms of its actions, then what I know is that that's going to be equal to T minus 2.3 times 9.8, which is my T minus mg, and that equals 2.3a. And Q is going to be 3.1 times 9.8 minus T equals 3.1a. So then to work this out, what I then need to do is use simultaneous equations, and I can use my calculator for this, in which I should get a T value of 25.9 and an A value of 1.45, and that's meters per second square. So this A value I've now worked out, and I can put that there. So now I've worked out the acceleration, I can now use SUVAT, because I know three other variables, to work out what V is going to be. So from this, what I can then do is, using V squared equals U squared plus 2AS, I get an answer of V squared equals 0 squared plus 2 lots of 1.45 multiplied by 0.8. So I get a V squared answer of 2.32, giving me a V value of 1.52, and that's meters per second squared. And then remembering that I need to round my answers up to two significant figures. So round final answer to 2SF, because we always, whenever we get prompted to give our answer to appropriate degree of accuracy, it's always the same level of accuracy that our G value is given in. So it's given to two significant figures, and you always want to think about significant figures rather than decimal places. So here my V value is going to be 1.5 meters per second squared. Now, if we have a look at question B, so question B asks us to find the time it takes for P to reach the pulley from the moment it is first released. Now, if we look at the diagram again, in which I've just kind of got rid of all the drawings that we needed for part A. Now, this distance we know is 0.8 meters, and this distance from the pulley of P is 0.9. Now, what we're going to notice at this particular point is that Q is going to hit the ground before P meets the pulley, because there's more string connected to P to the pulley than there is in terms of the string from Q, but it's still going to be going down because weight tells us that acceleration is going to be going in this direction here and is going to be going up in this direction here. Now, what we notice is that when P does hit the ground, then what's going to happen is, and again if I just draw this out quickly again, is that when Q hits the ground, that P is just kind of not going to be floating, but it's kind of going to be acting in terms of this distance here. And the distance from that to the pulley is 0.1 meters. And this has hit the ground. Now, what you're going to notice here is that when Q hits the ground, because it's coming down at force and with momentum, that P, as soon as it hits the ground, P is not just going to randomly stop. It's going to continue with some form of momentum heading upwards. Now, the fact that in this question it's asking us to calculate the time in which P reaches the pulley will imply that that momentum is going to take P all the way up to the pulley and actually connect with it. Now, the particle P can do one or two things. If it does reach the pulley, it's either going to hit the pulley and then kind of bounce back on the left hand side, or that P is actually going to wrap round the pulley and then go round the pulley and then potentially land on top of Q. But ultimately what we have is we have two particular stages. Now, the reason why we need to look at this in two different stages is because on the first stage, when Q is going down to the ground, so if I just call this stage 1, then what we know is that acceleration is traveling at 1.45 meters per second squared. And I know that from the working out that I did in the previous question. Now, at this particular point, if I call this point stage 2, then the acceleration of Q is going to be at 0. Now, the problem is that the acceleration of P is not going to be 0. It's going to be working under the forces of working against gravity. So at this particular point, P is going to have an acceleration of minus 9.8 in terms of working against gravity. So what I need to do to work out the time in which P hits the pulley, or reaches the pulley I should say, is I need to look at this at two different stages. Why? Because the acceleration is different for these two stages. So let's have a look at answering this question. So if I look at using SUVAT from part A, then with regards to stage 1, what I know is I know that SUVAT is that stage 1 is when Q hits the ground. And so P is travelled, remember we are talking about P, and that P is travelled 0.8 meters. It started at rest. V is going to be equal to 1.52 because it's travelling at the same acceleration velocity as what Q does when it hits the ground. A is going to be equal to 1.45 and T is what I'm wanting to know. Now, because I know 4 of the variables, I can actually pick and choose any SUVAT formula that uses T. So using, and I'm going to go for the one that looks the most easiest, V equals U plus AT. Doing a bit of substitution, I get 1.52 equals 0 plus 1.45 t. And doing a bit of rearranging and solving, I get a t value of 1.3 seconds. So at stage 1, it's taken 1.03 seconds. Now for stage 2, this is when P is acting under gravity. So P is acting against gravity. And again, starting up my SUVAT. So in terms of the distance that is left, so it's in stage 2, it's 0.1 meters. The initial velocity is the final velocity in stage 1, so that's going to be 1.52. Don't know the velocity in which the particle P reaches the pulley, so that's going to be blank. Acceleration is against gravity, so it's minus 9.8, and t is what we want. So finding the correct trig, the SUVAT formula that I'm going to use. So using S equals ut plus a half at squared, and substitute numbers in, I get 0.1 equals 1.52 t plus, and it's going to be, well, actually it's going to be minus, so let's just get rid of that. Now you might be asking, why am I using 1.52 rather than using 1.5? Is, again, it doesn't really matter in the context of this question. I'm using it just because I want to try and use the most accurate answer as possible. And because I'm going to be rounding up my final answer to 2 significant figures, if I go 3 significant figures, hopefully my final answer will not be affected too much. So then I get 9.8 over 2t squared. Now, slowly but surely, this is going to turn into a quadratic equation in which I get minus 4.9 t squared plus 1.5t minus 0.1. Actually, I'm going to change that to 1.5 only because most students will do that, and it's probably the same method as you would use as well. But again, if you use 1.52, then your answer might be slightly different to do this. Actually, let's keep it as 1.52 simply because we'll try and be as accurate as possible. 2, and so that should be minus 1.52t minus 0.1 equals 0. And working that out, I get 2 values of t. Now what I notice straight away is I get 2 positive values of t, and again, if I was to end up with a negative value, then I know that I could ignore the negative value because we can't have negative time. Now the fact that I've got 2 positive answers to t is expected because again, I'm solving a quadratic equation. Now for this, I need to make sure that I'm using the smallest positive value of t, because in the question it's asking us to find the time it takes for it when it's first released. So I need that first value when it meets the pulley, and that is going to be at this time here. So all that's left for me to then do is to work out the total time of both stage 1 and stage 2. So that's going to be 1.03 plus 0.0946, which when I type into my calculator gives me an answer of 1.12, and then I just need to make sure that I'm rounding that to 2 significant figures, which gives me an answer of 1.1 seconds, and there we go. So now let's have a look at our last example. So the last example says that 2 particles A and B of masses of 6.5 kilograms and 16 kilograms respectively are connected to a light inextensible string which passes over a light smooth pulley. The system is released from rest with particles of 2.6 meters above a horizontal plane. And it says, given that A does not reach the pulley, find the maximum height of A above the plane. Now the key thing, that this question may look similar to the previous question, but the key part of this is that the question says that given that A does not reach the pulley, find the maximum height of A. So looking at this particular question, let's just start by making sure that we're happy with in terms of the labeling. So here I've got my tension in my string, and these values here represent my mg value. So let me just go over that. So my mass is 6.5 kilograms and mg is going to be 6.5 g. And again, that there is my mg value. Then I need to look at what directions A is going in. So because B is heavier, it's going to be going down on this section and going up on this section. And in terms of this, what it's looking for is when B hits the ground. So if I just draw a little mini diagram, that when B hits the ground, that what I'm looking for is the highest possible part of A, including that little blip. So this is basically the blip in terms of the ricochet, the rebound, or the momentum of A when it kind of flicks up. Eventually it will hit down at that particular length. So if B is going down 2.6 meters, then this length here is going to be 2.6 meters, but it is going to bounce. A is going to bounce, and this H is what I'm needing to find along with the 2.6 meters. So ultimately, this is what I'm going to be using. So if I just mark this on the diagram because I've got a feeling I'm going to need the space for this particular question, then what I know is that if I say that this distance here is going to be 2.6 meters, and this is the H, or the height of my blip, is what I need to do. And the total height, or the answer in this particular question, is that H there, which I'll just call HT. So looking at this particular question, what I need to know is I need to work out what A is, because without A, I can't use my SUVAT. I'm not going to have enough variables to work this out. So in terms of working this particular question, the first thing I'm going to do is find A. Now to find A, what I need to do is I need to set up my two simultaneous equations. So just like we did before. So if I look at side A, then what this is going to be T minus 6.5G equals 6.5A. And then the side of B, that's going to be 16G minus T equals 16A. Then from this, just like before, and just to speed this up a little bit, we're then going to use simultaneous equations and our calculator to then work out what T and A is going to be. Now in this case, my T is 91 newtons, but my A is going to be 4.1 meters per second squared. And it's this value that I'm going to need next. So now that I've worked out my A value, I should now have enough variables for me to now move into SUVAT. So for number 2, what we then need to use is use SUVAT for stage 1 and 2. Now in terms of stage 1, what we need to notice is that at stage 1, it's basically the distance, or the section in which B has hit the ground and A is kind of at its particular travel 2.6 meters. So stage 1 is when B hits the ground. And remember, we've got two stages. We've got stage 1 where B hits the ground, and then we've got that blip. So at stage 1, what we've got, and let's have a look at what information we know. We know that distance is 2.6. The initial speed is starting at rest, so that's going to be 0 meters per second. V is what I'm wanting, and I'll explain to you why we're looking at V. And A is what we've just calculated, which is 4.1. And that's meters per second square. Now the reason why we want to work out V, and even though we know what S is because V is the only connecting value of SUVAT that connects stage 1 with stage 2. And the reason for that is because this V is going to equal the U in stage 2. And again, stage 2 is the blip. So it's the bit extra. Now, working out what V is, so knowing what I know, that I know S, I know U, I know A, so then using V squared equals U squared plus 2AS, I get V squared equals 4.617 squared plus 2 lots of 4.1 times 2.6, and ultimately that gives me a V value and that V value is 4.617 meters per second. So if this is 4.617, then this is going to be 4.167, our U value in stage 2. Now the distance is what I'm after, so I can write a little question mark there. Now, because V comes to a rest, now unlike the previous example where particle P reached the pulley, V is going to equal 0 simply because it's going to eventually come to rest. So that's why V is equal to 0. My A value is acting against gravity, so that's going to be minus 8.9, or 9.8 I should say rather. And again, it's always worth just making sure our units are consistent in terms of what we've got there. Now, using stage 2 data, what I can then do is now aim to work out what S is going to be. So working with this, what we can then do is we've got, and again we'll go for the set, we're using the same formula, so V squared equals U squared plus 2AS. Then what we get is we're going to get 0.416 naught equals, and it's going to be 4.617 squared plus 2 lots of minus 9.8s. Now again, doing a bit of rearranging and a bit of solving, we get an S value of 1.087 meters. So now that I know the height travelled in stage 2, I know the height travelled in stage 1, what I now got to do is now work out what H of the total is going to be. So this distance here is 1.087, this distance here is 2.6, and this distance here is also 2.6. So the total height of A above the plane, in other words the ground, is going to be 2.6 plus 2.6 plus 1.087, which comes up to a final answer of 6.3 meters to 2 significant figures. And there we go.